Hello, so today I'm going to be going over finding instantaneous rate of change. But first, before I go over instantaneous rate of change, I want to review average rate of change. Okay, so average rate of change is just finding the slope. So this is essentially the same thing as saying y2 minus y1 over x2 minus x1. The difference is our x's are a's and b's, and your y is found by evaluating these into the function that is given. Okay, so that's how you find the average rate of change. Now the average rate of change on a curve is going from 2 points. So this point to this point. This is called a secant line. Okay, but we want to look at a tangent line, like an instantaneous slope. Like if we wanted to find the slope at this point, how would we find it? Because there's no distance to go from here to here if we wanted to find it at that point. So we have what is called instantaneous rate of change, which looks like this. Now don't be scared, it does look scary, but it's really not. Okay, h equals b minus a. The difference is, though, is h is going to be like the difference between b minus a is going to be like 0.00000000000000001. Okay, so that's what that means, as h is approaching 0. So if I was looking for this point right here, my a, and let's just call this my b for a plus h, would get so close together. So this is h approaching 0 like that. That's what it's essentially doing. Okay, now let's look again at this average rate of change. So we have f of b right here. So let b equal a plus h. So we'll just put b a plus h right there. Minus f of a, and then b minus a equal h. And then all you got to do is just put a limit here saying that h is getting closer and closer to 0. And you have this equation. Okay, so that's how we find the slope of a tangent line. So let's find the slope at a point. So we're going to be finding the slope of the curve of f of x at x equals a. Okay, so I started this one. So here's the formula. So the limit is h approaches 0 of f of a plus h minus f of a over h. Two ways you could simplify this or do some algebra. One, go ahead and plug a plus h in here. So you would have a plus h squared minus f of a over h. Or you can go in and plug the 2 where you see a, which is what I did here. So limit, so where I see a, I'm going to put 2. So f of a, which equals 2, plus h minus f of 2 over h. You could also find it like that as well. So let's go and do that. So f of 2 plus h. So this is just like a composition function. So where I see x in f, I'm going to put 2 plus h. So that's going to be, so don't forget to write your limit every single time. Points will be taken off if you do not write your limit every single time until you can substitute it in. Because right now we can't. If you put 0 in here, we're going to get 0 in the denominator, and that's not going to work. If you do that, you're going to get it wrong, and you're going to lose a lot of points. Okay, so anyway, here. So where I see x, I'm going to put 2 plus h. So f of x is x squared, so there's a parenthesis there. Okay, so there's my x, so now I'm going to just drop 2 plus h right there. Okay, my next one is f of 2. So f of x is x squared, so there's like my x squared with parentheses, and then I'm just going to plop in 2. Okay, and now it's just a bunch of algebra. So this is 2 plus h times 2 plus h. It's 2 plus h minus 2 squared, which is 4. So you get the limit as h approaches 0 of 4 plus 2h plus 2h, which is 4h plus h squared minus 4 over h. So this is the part where usually you can go ahead and cancel out some things. So 4 minus 4 is 0. So you're left with 4h plus h squared. So now you could factor, I'm just going to write it neat here so you can follow along. I don't want to skip steps. So now here's your opportunity to get rid of that h. So you get rid of the h by greatest common factoring. The h is right there. So you have the limit as h approaches 0 of h times 4 plus h over h. That goes away. Now you can go ahead and put 0 where you see h. So you're going to have equal to 4 plus 0, which is 4. And that is your answer. So that is going to be your slope of x squared plus 2 at a equals 2. Okay? Alright, so now let's talk about tangent lines. Okay? So tangent lines, this is the line, so you have the point right here. So if I do this one, just put the graph over here. So we have x squared. Okay, here's my 2. So I'm right here, so 2. So my tangent line is going to be the line that like kind of glides along that path like this. That's my tangent line right here. Okay, and I know now that my slope is my slope at 2 is going to be 4. Okay, so find the equation of the tangent line at a point on a curve. So find the slope of the line m of t at x equals a. So that's the first thing you do. Now, well, you could do this part first. Using the given x value, find the y value by evaluating x into the given equation. Therefore, you're going to get y equals f of a. Okay, so like here, if I was doing it here, to find my y coordinate, I would just put 2 in here. So I would be starting at 2, 4. That's where I would be starting. That's where my tangent line will be starting right here at 2, 4. That 4 has nothing to do with that, by the way. Okay, so you could either do B, then A, then C, or you could do it like this. It just depends on what you want to do. So you can find the slope of the tangent line x equals A. Then you need to find your point of the original function before you find the slope here. And then you can use point slope form, which is obvious. Then to find the equation of the normal line, same thing as you did in like algebra 1, you're going to use the opposite reciprocal slope of the tangent line, use the point from here, and then go ahead and plug it into point slope form. So determining whether the tangent line is horizontal, you're going to set the general slope of the tangent line equal to 0, and then you're going to solve for x. Okay, so let's go. So that's the first one we're going to be doing. At what point is the tangent of 3 minus 4x minus x squared equal to 0? That's what we're going to be doing. So we're going to have 0, okay, because a horizontal line in the slope is 0. Remember that. If I had like this right here and I had the line of like y equals 2, my slope at y equals 2 is 0. Okay, that's what it looks like. Now this is a parabola, so I'm not saying it's going to look this. It's going to look like something like that. So the tangent line is going to be, we're going to be looking at a maximum here. But anyway, so at what point is the tangent to this horizontal? So this is going to be limit as h approaches 0 of f of, you can do either x or a, it doesn't really matter. Your books are going to be doing using a's and t's and x's. It does not matter. Okay, I'm just going to use x. Okay, it's the same one, you know, we're just using x instead of a right here. Okay, so now I'm going to plug this in. So where I see x in here, I'm going to put x plus h. Okay, so here's my f of x. So I'm going to have 3 minus 4. So that's going to be where the x is, minus x squared. Okay, so where I see x, I'm going to put x plus h minus f of x. So f of x is this whole thing right here. Don't forget to put a parentheses in here because you don't want to forget you're going to be distributing that. Okay, now it's algebra. 0 equals the limit as h approaches 0 of 3 minus 4x minus 4h, so distributing the negative 4, minus x squared plus 2xh plus h squared. So x plus h times x plus h, you're going to get that after you FOIL. Minus 3 plus 4x plus x squared over h. 0 equals a limit as h approaches 0 of 3 minus 4x minus 4h. Now I'm distributing the negative. Minus x squared minus 2xh minus h squared minus 3 plus 4x plus x squared. Okay, so now it's time to cancel things out. So 3, just look for another for a minus 3. Boom, right there. So that's gone. Okay, negative 4x, so I got negative 4x. So negative 4x plus 4x is 0. That's gone. Negative 4h, there's no negative 4h. Negative x squared plus x squared. So you have 0 equals a limit as h approaches 0 of negative 4h minus 2xh minus h squared over h. So you can factor out h. So 0 equals the limit as h approaches 0 of h negative 4 minus 2x minus h over h. Cancels out. So you can go ahead and plug in there. So I'm just right there. So you have 0 equals the limit as h approaches 0 of negative 4 minus 2x minus h. Go ahead and plug in 0 right here. So you have 0 equals negative 4 minus 2x, because minus 0. Solve for x. So you're going to have 4 equals negative 2x, so x equals negative 2. Okay, that is our x value at which this point is horizontal. So in order to find the y value, you're going to plug negative 2 into the original equation here. So y is going to equal f of negative 2, which is going to be 3 minus 4 times negative 2 minus negative 2 squared. So you have 3 plus 8 minus 4 plus 3 is 7. So your point is going to be at negative 2, 7. All right. Next example. At the indicated point, find A, the slope of the curve, B, the equation of the tangent, and C, the equation of the normal. Then draw a rough sketch of the graph. So let's go ahead and find the slope first. So this is going to be the limit as h approaches 0 of f. I'm going to go ahead and put where I see x, I'm going to put 1. Again, it doesn't matter if this is a or x, it means the same thing. 1 plus h minus f of 1 over h. That's my formula. Okay, so now I'm going to evaluate this. So where I see x in here, I'm going to put 1 plus h, so I'm going to have x squared minus 4x. Okay, so there's f of x, so I'm just going to drop 1 plus h into the parentheses. Okay, so now I'm doing minus f of 1. 1 squared minus 4 times 1 over h. So limit as h approaches 0 of, so that's 1 plus h times 1 plus h, which is going to be 1 plus 2h plus h squared minus 1 minus 4 is negative 3, so that's going to turn into a positive 3. Oh, I forgot to distribute here, sorry. So I foiled this, 1 plus h squared, that's that, minus 4 minus 4h. Now I'm here. So then you have minus a negative 3, which is going to be a plus 3. Now I knew I made a mistake because usually these whole numbers cancel out, so that's how I knew to kind of double back. Okay, so 1 minus 4 is negative 3. Negative 3 plus 3 is 0. So that's going to give you the limit as h approaches 0 of 2h plus h squared minus 4h over h, greatest common factor, that h. Two plus h minus 4. Alright, like terms. Cross that out, you get the limit as h approaches 0 of h minus 2. Go ahead and put 0 in here. So, oh, don't forget m equals this, because that's your slope. Don't ever forget this means your slope. H minus 2, so you get negative 2. So m, so that is our slope. So our slope of a curve is negative 2. Okay, that's A. B, the equation of the tangent line. So remember in algebra 1 or algebra 2, you need a slope and a point. So to find the point, we're going to put this x value into here to get our y. So we have our slope. Our x value is 1. That's what we started with. Now to find our y, that's going to be f of 1, which is going to be 1 squared minus 4 times 1. And that's going to be negative 3. So we have our slope at 1, negative 3. So to find the tangent line, point slope form, so y equals m times x minus x1 plus y1. So you get negative 2x plus 2 minus 3, negative 2x minus 1. So that's our tangent line. Now we're going to find our normal line. Our normal line is just our perpendicular line. So see, so my perpendicular slope is going to be positive 1/2. And our point doesn't change. 1, negative 3. Point slope form again. So y equals 1/2 x minus 1 minus 3, which is 1/2 x minus 1/2 minus 3. I'm going to go ahead and do 2 over 2, which is 6 over 2. So my normal line is going to be 1/2 x minus 7/2. So that's my normal line. Okay, now it wants me to graph it. So we got x squared minus 4x. So let's see, our x-intercepts are going to be at 0 and 4. Let's see, we're going to have x, I'm doing a complete square to find the, or negative b over 2a. So x equals, I guess it doesn't really have to be perfect. X equals negative b over 2a. I'm finding the vertex. You could also do this by complete square. So that's going to be 4 over 2, which is at 2. And that y value of 2 is going to be 4 minus 4 times 2, which is 8, negative 4. So 2, negative 4. Okay, tangent line is at, so we're looking at a point of 1, negative 3. So here's 1, negative 3. That's where we're looking at. Our tangent line is negative 2x minus 1. So negative 1 down 2 over 1 down 2 over 1 up 2 over 1, something like this. Okay, that's our tangent line. Okay, and then our perpendicular line is just going to look something like this. Just there's your perpendicular line. Okay, so that's all the parts of that question. So find the slope by putting into this equation. So we got a slope of negative 2. Then you need to find a point. So this was the part on the earlier on the video where I said you could flip-flop finding the point and then find the slope. It doesn't matter. So yeah, you find the point by, here's your x equals 1, and then you find negative 3 by plugging that in here. Okay, here's another one. So f of x equals 1 over x plus 4 at x equals 2. So you're going to find the slope, which is the limit as h approaches 0 of 1 over x plus 4. Let me put the equation. F of 0 plus h minus f of 0 over h. That's better. So that's the start. I was just getting ahead of myself. And that's going to be, so 1 over x plus 4, so this is going to turn into a complex fraction. So the limit as h approaches 0 of 1 over, so there's x, I'm just going to put a parentheses there. So where I see x, I'm going to put 0 plus h, which is just h. Minus f of 0, which is going to be 1 over 0 plus 4 over h. Let's make that look a little better. So the limit as h approaches 0 of 1 over h plus 4 minus 1 over 4 over h. So complex fraction. So to get a complex fraction out, I call this the main numerator, this is the main denominator. So I focus on all the denominators here, here, and this denominator is 1, so I really don't care. So the LCM is going to be 4 times, or 1 times 4 times h plus 4. You're going to multiply everything by the LCM. When you do that, you're going to get rid of all the denominators. So you're going to have 4 times h plus 4, 4 times h plus 4, and then 4 times h plus 4. So as you can see, they cancel out. So h plus 4 is gone, and 4 is gone. Now when we go to the next step, do not distribute this because this h will cancel out later on. So that's going to be 4 minus h plus 4 over 4h times h plus 4. So that's going to be 4 minus h minus 4 over 4h times h plus 4. Oops, limit. The limit as h approaches 0 is going to be negative h over 4h times h plus 4. That cancels out. Okay, go and substitute in the 0. So you have negative 1 over 4. So your slope is negative 1 over 4. So now you have to find the tangent line. So to find the tangent line, you need a slope and a point. So back here at x equals 0, so our x equals 0, and our y is going to equal to f of 0. So that's going to be 1 over 0 plus 4, which is 1/4. Okay. So now we're going to do our tangent line. Okay, so we're going to have y equals negative 1/4 x minus 0 plus 1/4. So y equals negative 1/4 x plus 1/4. And I forgot about that 4 being there, sorry. So that's going to be 4 times h plus 4, which is going to be negative 1 over 16, sorry. So my slope is negative 1 over 16. Okay. So, yeah, I accidentally forgot to put it over here. The perpendicular slope, so that's my tangent line. Now my normal line is going to, so my slope is going to be positive 16 at 0, 1/4. So that's going to be y equals 16x plus 1/4. Okay. The graph, so we've got a vertical asymptote at negative 4. And a horizontal asymptote at 0, so it's going to look something like this. 2, 3, 4. Okay, and we are looking at 0, 1/4. So we'll just call it there. Tangent line is going to look something like this. Kind of guide along the line, and then your perpendicular line is going to look something like that. Okay, so rough sketch, I can do it. Okay, instantaneous speed, it's the same formula we've been doing. The only difference is that's not an A or an X, it's a T. So that's just T is for time. So at t seconds after liftoff, the height of a rocket is 3t squared feet. How fast is the rocket climbing after 10 seconds? So if you remember on a distance time graph, the slope of those is the speed. That's where you're getting that from. Okay, so time, distance, this is the speed. Average speed is the slope. So instantaneous speed, same thing what we've been doing. So that's just a linear one. We're doing a quadratic one, so it's going to look different. So this is going to be the limit. So V is going to be the limit as h approaches 0 of f of our seconds are 10. 10 plus h minus f of 10 over h. Y'all are going to get so good at these. Equals limit as h approaches 0. Here's our function right there. So where you see t, I'm going to put 10 plus h. Okay, so that was my function, 3t squared. Minus f of t, so f of 10, so that's going to be 3 times 10 squared. And then I have equal to the limit as h approaches 0 of 3 times 10 plus 20h plus h squared minus 300 over h. wait, 10 times 10 is 100, so there should be 100 right there. Okay. So that's going to be limit as h approaches 0 of 300 plus 60h plus 3h squared minus 300. Okay. 300 minus 300 cancel out. So you got 60h plus 3h squared. I'm going to go ahead and greatest common factor that on the next step. Of h, 60 plus 3h over h. h's are gone. So now all you have to do is plug in 0 for h, which is 60. And it's going to be feet per second. Okay? So remember, this is feet, this is seconds. Feet per second. Okay? And that is it for the lesson. So just check your email for your homework. Have a good night or day whenever you're watching this. Bye.